Hello students, in our previous video we discussed about the mixed combination of sets. After that, next concept is in that one we discussed what is the equivalent EMF of these sets, what is the equivalent internal resistance of these sets, what is the total resistance in these sets, that is the circuit, total resistance in that circuit, and what is the current passing through the circuit. At the same time, in which situation the current becomes maximum. All those things we learned in the previous video. Okay. Next one is the potentiometer. Potentiometer. What is potentiometer? Why we are using this instrument? That the construction theory, that is the principle of the potentiometer. Next one is what is the applications of the potentiometer. All those things we are discussing one by one right now. So here first one is the potentiometer. Potentiometer. First of all, what is potentiometer? Potentiometer is a device. Potentiometer is a device. What is the use of that potentiometer? So we can find out the internal resistance of the cell. We can find out or determine the internal resistance of the cell by using the potentiometer. Or in case of in the circuit, in between any 2 points, if we want to find out the potential difference, that potential difference is also measured by using the potentiometer. So the same thing is done by the voltmeter also, yes. But in case of the voltmeter, compared to the potentiometer, in that value, error is more. So here, by using the potentiometer, if you find out the potential drop or potential difference between the 2 points in the given circuit, that is the more accurate. That is the more accurate. That's why here we are using the potentiometer. At the same time, one more is the comparison of the EMF of the cells. Which cell have the more EMF? Which cell have the less EMF? These are determined by using that is the comparison of the EMF of the cells. These are the uses of the potentiometer. Those are the uses of the potentiometer. So here first of all, construction. What is the construction? Construction of the potentiometer. In case of the construction of the potentiometer, this potentiometer consists of the 1 meter wooden board. Potentiometer consists of the 1 meter wooden board. This is the 1 meter wooden board. So on this wooden board, 10 meter wise, all have the same, that is the equal area of the cross section. 10 or maybe somewhat less also, no problem. So if we take the more length of the potentiometer wire, the accuracy is also more. Sensitivity of the instrument, that is depends upon the length. Sensitivity of the potentiometer depends upon the length of the potentiometer wire. So that's why we are taking the 10 meter wise, all have the same uniform cross section wise, all are stretched parallel to each other like this. So at the same time, here these wires are connected by using a copper strips, the ends of the wires. How those are connected? Observe. So by using the copper strips, we can form the single wire. So right now, total length of the wire of the potentiometer, that is the 10 meters. By using the copper strips, we have connected the ends and form the single wire. So here AB is the potentiometer wire. AB is the potentiometer wire. So 10 meter wires all have the uniform cross sectional area or placed or stretched parallel to each other. By using the copper strips we can connect these wires. Due to that we can form the big wire. That is the here total this one right now there is the total one wire only. What is the length of the potentiometer wire? Nearly 10 meters, not nearly 10 meters, 10 meters. So here these starting and ending terminals of the wire, that one have screws, that one consists of these screws. That one is consists of these screws. Actually these A and B, these are connected to the battery. This is the battery having the EMF something, E volts. At the same time, this one consists of the one series resistor. Yes. So here, this is the RS, internal resistance of the cell. I am representing here, this is the internal resistance, that is the small r. Length of the potentiometer wire, that is equal to length of the potentiometer wire is equal to capital L, and its resistance is equal to capital L is the length of the potentiometer wire. So, and resistance of that wire is equal to capital R. Resistance of the wire is equal to capital R. Observe here, three resistors are there. One is the internal resistance of the cell. Second one is the series resistor. Some resistance box, we kept some resistance box. At the same time here, this one is the potentiometer wire. That wire have some resistance that is represented with the letter capital R. L length of the wire have the resistance that is the capital R. Therefore, total resistance in that circuit is equal to how much? Total resistance R total is equal to small r plus Rs plus capital R. All are connected in the series combination only. So at the same time, in the construction, one more is also there. That is the 1 meter scale is placed beside of the potentiometer wire to measure the length, the balancing length of the potentiometer. To measure the balancing length of the potentiometer. Here this is the scale. That is the scale. So here total resistance in the circuit, small r plus capital Rs plus R. This is the total resistance in the circuit. EMF of the battery is equal to E. EMF of the battery is equal to E. Therefore, total current passing through this circuit is equal to how much? According to the Ohm's law, V is equal to I into R. But here we are represented that EMF is equal to E. E is equal to I into R total. R total means small r plus Rs plus capital R. So current, therefore current I is equal to capital E by small r plus Rs plus capital R. This is the total current passing through this potentiometer wire. Or maybe if you are taking potentiometer, this in this circuit, current passing through this circuit is equal to E by small r plus capital Rs plus R. Rs plus R. Generally here they may be given the RP resistance box also, no problem. So current is equal to E by R plus Rs plus capital R. Plus capital R. So this is the construction of the potentiometer. Next one is the, what is the principle of the potentiometer? Principle of the potentiometer. What is the principle of the potentiometer? So if you observe, yes, I will draw the one more circuit diagram. Yes. So here I am represented this total AB is like a single wire. This is the potentiometer wire. AB is the potentiometer wire. And here this is connected to the battery having the EMF E, and this one is the internal resistance. We are not represented the internal resistance also, no need. This is the series resistor Rs. So total this circuit we are represented like this. This is we are calling the primary circuit. Primary circuit. So EMF of the battery is equal to E, current is equal to something I amperes. So right now here if you take another battery, that is a cell having the EMF something V or maybe take this one is the battery and this is the, yes, here is also a battery having the EMF, that is the battery having the EMF E. So I am referring to there is the battery. Here we are taking the one cell having the EMF something E1. So from here onward, this is connected to the galvanometer and that is connected to the jockey J. So here below the potentiometer wire, this circuit we are calling the secondary circuit. Above the potentiometer wire, that is the primary circuit. Below the potentiometer wire, this is the secondary circuit. Secondary circuit. So, in case if this jockey is moving from point A towards the point B, now we are discussing the principle of the potentiometer. What is the principle of the potentiometer? Observe. So, if when current is passing through this wire, potentiometer wire, across the length of the wire, the potential is decreases. That is, we are calling the potential drop. So, when this current is passing through this wire, across the length of the potentiometer wire, its potential drop, that is the potential drop across the length of the potentiometer wire is directly proportional to its length. Yes, one more time, don't get confusion. So observe, when in case if you are taking potential drop V is equal to I into R, according to the Ohm's law, V is equal to I into R. When this resistance is more, current is not changing. Here current is not changing. Same battery we are using, same resistors. So resistance of the wire is not changing. But for the parts, why? Because the resistance of the wire is directly proportional to its length. So therefore, directly proportional to its length means here length is increases from this one. V is equal to I into S. R is equal to rho into L by A. So from here, rho into L by A, rho is the specific resistance, that is the constant. I is the current passing through the circuit, that is also constant. A is the area of cross section of the wire, that is also constant. So from here onwards, all these are the constants. Therefore, V is directly proportional to L. The potential drop across the length of the potentiometer wire is directly proportional to its length. When balancing length is increases, potential drop is also increases. Yes. When this jockey is moving from point A towards the point B, then potential drop across the length of the potentiometer wire is directly proportional to its length. Here, this V is equal to the, yes, this potential drop, V is nothing but the potential drop. In case, here if you are taking the 1 meter wire, remaining all are the constant, potential drop, V1 is equal to 1 volt. In case, if the wire is equal to 2 meters, what is that wire? Yes. Jockey is moving from point A towards the point B for the length L meters. Means now this jockey is at the point something P or maybe N1. In that situation, potential drop across the length of the potentiometer wire, I am taking that is equal to V or maybe V1. So this V1 is directly proportional to L1. I am taking this is the length L1. In case if you are taking the L2 length of the potentiometer wire, in that situation potential drop is the V2. V2 is directly proportional to L2. So means here potential drop across the length of the potentiometer wire is directly proportional to its length. is directly proportional to its length. This is the principle of the potentiometer. This is the principle of the potentiometer. The potential drop across the length of the potentiometer Y is directly proportional to its length. Or maybe if you are writing this one, V by L is equal to constant. V by L is equal to constant. So V by L is equal to constant. So means V by L, potential per length, that is nothing but the potential gradient. But potential gradient is equal to constant. Potential gradient is equal to constant. So this is the principle of the potentiometer. Potential gradient is equal to constant. That is also same. Potential gradient is equal to constant. That is the principle of the potentiometer. Principle of the potentiometer. Next one, what is the uses of this potentiometer? Already we discussed that one. What is the uses of the potentiometer? Already we discussed that one. To determine the internal resistance of the cell, we are using the potentiometer. Next one is the comparison of the EMF of the cells. For that purpose also we are using the potentiometer. Okay, first one here. So comparison of the EMF of the cells. Compare the EMF of cells. Compare the EMF of cells. So means, what is the meaning of the compare the EMF of the cells? Which cell have the more EMF? Which cell have the less EMF? Which cell have the more EMF, or maybe which cell have the less EMF? Okay, right now we will find out it. So here this one is the potentiometer Y. Observe, this is the potentiometer Y. Same Y, AB. I am not writing the total length of the potentiometer Y. Total length of the potentiometer Y. Okay. So first of all, here A is connected to the battery positive terminal of the battery, and here a series resistance or maybe resistance box. We kept the resistance box, and that is connected to the last terminal of the cell. Last terminal of the, that is the potentiometer Y, not cell, potentiometer Y. So here total, this is the primary circuit. Here this one is the battery. At the same time, which cells, if you want to compare it, those two cells positive terminals are connected at point A. Here battery positive terminal is connected to the A. At the same time, which cells we want to compare it, those two cells positive terminals are connected here along with the keys. Yes. So here this is the first cell and the second cell. This is the first cell having the EMF V1 and key. This is the key K1, and this is the second cell having the EMF V2 and key is equal to K2. And this is connected to the galvanometer and is connected to the jockey. So in the first case, K2 is open and K1 is closed. K2 is open and K2 is open and K1 is closed. Right now, cell, that is the first cell is in the working, not the second one. First cell is in the working. Right now, this is the closed circuit. So right now, if this jockey is moving from point A towards the point B at a point N1 for the balancing length L1. In that situation, this galvanometer shows the zero deflection. Means the potential drop across the length of the potentiometer Y. That is equal to the EMF of the first cell. Potential drop across the length of the potentiometer Y. This one shows the zero deflection. When this deflection becomes zero, means potential drop across the A to N1. What is the potential drop across the A to N1? So in that situation, I am taking that one is equal to V1. Right now this V1 must and should equal to the EMF of the first cell. EMF of the first cell. So according to the principle of the potentiometer, V is directly proportional to L. Here potential drop across the length of the potentiometer wire is the V1, that is equal to the E1, EMF of the first cell, is directly proportional to balancing length, that is the L1. L1. So next one, in the second case, this is in the first case, and in the second case, so in that situation, K2 is closed and K1 is open. K1 is open. When K2 is closed and K1 is open, then what happened? Right now, this is not in working. First cell is not in working, but second one is in working. The same process is repeated for the second time also. That is for the cell E2 also. For the balancing length L2 at point N2, that is the N2 jockey J. For the balancing length L2, in this situation, this galvanometer shows the zero deflection. When this galvanometer shows the zero deflection means the potential drop across the A to N2, that is we are taking something V2. This V2 is must and should equal to the EMF of the second cell. According to the principle of the potentiometer, V is directly proportional to L. From this one, V2 is equal to E2, that is directly proportional to L. This is the equation number 1 and this is the equation number 2. Equation 1 by equation 2, that implies E1 by E2 is equal to L1 by L2. E1 by E2 is equal to L1 by L2. So, in case if you take an example, sir, something L1 is equal to something to 3.5 meters and L2 is equal to 4.5 meters. 5 meters. Actually, total length is the nearly we are taking 10 meters of the wire. So L1 is equal to 3.5 meters and L2 is equal to 4.5 meters. So means here E1 by E2 is equal to 3.5 by 4.5 means E1 by E2 is equal to 7 by 9. Therefore E2 is equal to 9 by 7 times to that of the EMF of the first cell. So here which one is the big means more EMF of this cell? Second cell is the more EMF. In this situation, in this example, E2 is equal to 9 by 7 times to that of the E1 means EMF of the second cell is more comparative to the EMF of the first cell. EMF of the first cell. Next one, that is the internal resistance of the cell. How to determine the internal resistance of the cell? Okay, we will discuss that one in the next video. Bye all.